Paralleling breakers for chiller power is a viable solution to address limited capacity. However, careful consideration and code compliance are essential. Article 408.16 of the National Electrical Code permits paralleling of overcurrent devices for loads exceeding the current carrying capacity of a single overcurrent device. The feed conductors must be sized to carry the maximum load that can be supplied by the parallel breakers. For example, 125 amps. The overcurrent devices breakers in this case must be rated for the combined maximum current, for example, 200 amps. The disconnect must be marked as fed from multiple sources and rated to handle the total load, for example, 200 amps. The parallel breaker should share the load evenly. Proper sizing and routing of conductors is crucial to minimize imbalances. Each breaker should be set to trip at the National Electrical Code specified overload threshold for the feeder size, for example, 150 amps for 1/0 conductors. This ensures that one breaker tripping does not overload the other breaker. The conductors from each parallel board to the disconnect must be sized for the total load, for example, 1/0 copper. This includes the rating for parallel runs. The length of the conductors must be considered when selecting the conductor size to minimize voltage drop. Advantages of paralleling breakers: firstly, it is cost-effective. This avoids the costly expense of installing an additional service. Secondly, it offers simplicity. This utilizes existing electrical infrastructure and minimizes disruption. Thirdly, it offers increased reliability. Paralleling breakers provides redundancy in case of a single breaker failure or load imbalance. Paralleling breakers for the chiller power supply is an acceptable solution as per National Electrical Code regulations. However, it requires proper planning, sizing, installation, and code compliance to ensure safe and reliable operation. It is recommended to consult with a qualified electrician to verify the feasibility and execution of this approach.